So now let's talk about fractional slash relative abundance. So the abundance is the availability of the element, or the one you see frequently. So that is it. So out of all the isotopes that exist, which one that you see frequently? So that is it. So like in chlorine 35 and also chlorine 37. So I have 17. So chlorine 35 has the highest abundance, that is the highest availability. So that is it. So how can we now calculate? Yeah, we want to calculate the relative atomic mass of all the isotopes that exist. So to calculate, this is the general formula. We have m1. M is the mass number or atomic mass. So m1 p1. So where p will be the percentage of the abundance. So plus m2 p2 plus, so we can have dot dot dot, means depend on the number of isotopes that you have. So m3 mn pn, so meaning any number, so like m1000 p1000 continue. So that's what the formula means, divided by the sum of the percentages. So you have p1 plus p2 plus up to pn. Know that n is any number, just like the way we say p1 p1, m1 p1, m2 p2. Instead of us to continue till infinity, so we can just say mn pn, where n is any number. So again, p1 p2 p3 p4, as in up to pn. So this will be the general formula for the relative atomic mass. So take notes. RAM is relative atomic mass. Then M is mass. This one, relative atomic mass of isotopes. Let's put it that way. RAM is relative atomic mass of isotope. Then M is the mass number or atomic mass. Then P is percentage or the abundance. So the percentage of the availability. So the percentage of their abundance. So like that. So now, this same formula can also be relative atomic mass, can also be M1, F1, can also be M1, F1 plus M2, F2 plus Mn, Fn. So in case it is not the abundance, or the abundance is not in percent, the abundance can also be in fraction. So where F is the fractional abundance. So like that. Now let's see how we can use this formula to solve question. Now let's see example. Example: calculate calculate the relative atomic mass of an element with two naturally occurring isotopes. So we have isotopes. Isotopes. So the isotopes, we have element X with mass number 63 or atomic mass 63. We also have element S with atomic mass 65. So that is different atomic mass. So we have isotope mass. So we have isotopes, that is X 63, 65. So isotope mass, we have 62.930, and we also have 64.928. So that means it's this isotope mass you will use, because this is average. So if we approximate 62.9, you get 63. If you approximate 64.9, you get 65. So we are going to use the isotope mass. So also we have fractional abundance. So fractional abundance, we have 0.6909, and we have 0.3091. So like that. So this fractional abundance serve as percentage. Now if it is percentage that you have, you use the first formula. If it is fractional abundance that you have, then you use this to calculate your relative atomic mass. So you will use M1 F1 plus M2 F2. Remember, we have just two isotopes here. So, and we have just two fractional abundance. So I'll just stop at M1 F1 M2 F2, since I have just two fractional abundance. But if it is not fractional abundance that you have in your question, if it is percentage that you have in your question, then you use the formula relative atomic mass M1 P1 plus M2 P2 divided by P1 plus P2. That is if it is percentage that you have in the question. But since I have fractional abundance, not percent, so I'll use this formula. Please take note. So now let's substitute everything. So we have M1 already. So this is our M1. This is our F1. This is our M2. This is our F2. So now just substitute in the formula. So we are going to have So we have RAM, that is relative atomic mass, will be equals to, now M1, that is 62.930. So 62.930 times F1, that is 0.6909. 0.6909 plus M2, we have 64.928. 64.928 times F2, that is 0.3091. So what you need now is to press your calculator. So press your calculator. We get 62.930 times 0.6909. So we have 43 points. So relative atomic mass is equals to 43.478 plus then 64.928 times 0.3091. So we have 20.0692. So add the two together. So relative atomic mass is equals to 20.0692 plus 43.478. So that is 63.5472. So that is the relative atomic mass. So the one that has the highest abundance here is the X63, meaning the one that has the highest availability, because 0.69 is bigger than 0.30. So that means X63 will have the highest abundance, and that is the one that you will see in your periodic table if you will see number. So that means this is, we can approximate this to 63.5. So like that. So that is your relative atomic mass. So relative atomic mass is fraction, so units will cancel out. So that's why in periodic table you don't have units there. But relative molecular mass, we have the unit gram per mole. So relative atomic mass, relative atomic mass and relative molecular mass, if you have molecule or you have atom. But if you just have relative atomic mass, is different from molar mass. Take note. So molar mass, we have a unit which is gram per mole. That means relative molecular mass of an element is still the same thing as finding your molar mass, but if you put gram per mole, we will know it's molar mass. That means molar mass is the relative atomic mass in gram per mole. For example, now this is relative atomic mass 63.5. If I say molar mass, I'll put the unit gram per mole. Putting this unit there, it is molar mass. But without the unit, it is relative atomic mass, as in like that. So take note. So now let's see another example. So that is one example. Let's say we have chlorine. Another example, chlorine has two isotopes. Chlorine has two isotopes. Sorry, let me spell it well. Chlorine has two isotopes. Sorry, let me correct that. It is chlorine has two naturally occurring instead. Chlorine has two naturally occurring isotopes with 35 and 37. If the RAM, that is relative atomic mass of chlorine, is 35.5, what is the percentage what is the percentage abundance, that is what is the availability, so the one that has the most abundance, what is the percentage abundance of the two? So we want to check their availability. What is the percentage abundance of the two isotopes? So we want to have the percentage of the two isotopes. So first, let's use the formula. Relative atomic mass will be equals to M1 P1 plus M2 P2 divided by P1 plus P2. Now take note that this is percent, and normally total percent must be 100%. Even though you have 10 isotopes, you must add all the percentage, and if you add all the percentage, it will sum up to 100. So now that is the techniques we are going to use here. Since we don't know the percentage abundance, so we can say let the percentage abundance let the percentage abundance P1 be equals to X. And remember, P1 plus P2 must be equals to 100. So now that we say P1 is X, that will be X plus P2 equals to 100. So P2 will be equals to 100 minus X. So that if you sum the two, it must give us 100. So if P1 is X, P2 will be 100 minus S. So let the percentage abundance P1 be X. Also, percentage abundance P2 is also S. Let the percentage abundance P2 so be equals 100 minus S, as I've shown, because P1 plus P2 must be 100. So if P1 is 40, for example, P2 will be 100 minus 40, that will be 60, so that the sum of the two must be 100. But because we don't know the P, we say let P1 be X, so P2 will be 100 minus X. So now let's put it in the formula. Remember, we have relative atomic mass in the question, that is 35.5. So you will have 35.5 will be equals to M1, so the mass for first isotope is 35. So that will be 35. P1, so we set P1 to be X, so that will be P1X plus M2, that is the second mass, that is 37, times P2, that is 100 minus S. So like that. Everything divided by P1 plus P2. So that will be X plus 100 minus X. So from here, we are going to cross multiply and solve for X. So we can now find P1 and P2. So I'll write that again. Remember your P1 and P2. So here we have 35.5 to be equals to 35x bracket 100 minus s over x plus 100 minus s using the same formula. So now this will be 35.5 equals 35s plus 3700, open the brackets, so you have 37 times 100, so minus 37s everything over 100, because x minus s is 0. So we have 35.5 equals now 35s minus 37s, so that will be minus 2x plus 3700, everything divided by 100. This is over 1, so we can now cross multiply. So 1 times, so minus 2s plus 3700 will be equals to 35.5 times 100. So you just move 2 zeros to the right. So 35.5 times 100. So that will give you 3550. So now collect like terms. So minus 2s will be equals to 3550 minus 3700. So minus 2s is equals to, now subtract 3550 minus 3700. So we have minus 150. So x is equals to minus 150 divided by 2. S divided by minus 2, because we are dividing both sides by minus 2. So 150 divided by 2 will give us 75, because minus will cancel minus. 150 divided by 2 is 75. Now that we know x, remember that is P1. So P1 is equal to 75%. Or if you change it to a fraction, that will be 75 divided by 100. That will be 0.75. This is percentage abundance, while this is fractional abundance. So this percentage is in percent, but we change it to decimal. So that's why we call it fractional abundance, as in 75%, or in decimal, like that. So we know that P2 is 100 minus X. So definitely P2 will be equals to 100 minus 75. So P2 is equals to 25%, or 0.25 if you change it to decimal. So the two, now we have known our relative abundance for each isotope. So now the most abundance is the 75%, which is for chlorine 35, and that is why in your periodic table you see 35.5 as the relative atomic mass for chlorine, because that is the most abundance. The chlorine 35 is the most abundance. So now the two abundances are 75% for chlorine 35, atomic number 17, and 25% for chlorine 37 with atomic number 17. So that means this one occur most. That is, we say this one, the availability of this one is high, chlorine 35. And that is why you see it in your periodic table. So the periodic table carry 35.5 to show your relative abundance. So that is how to solve this question. So we move.